Welcome everybody to day 14. Today I'll be going into a deep dive of deployments. So let me get started to understand deployments at even a very, very deeper level. So deployments, a deployment manages a set of pods to run an application workload, usually one that doesn't maintain state. Okay. So a deployment simply helps us to manage pods. So the deployment provides declarative updates for pods and replica sets. And now we've looked at deployments, at pods, at replica sets, but now this is going deeper into these matters. Next up, it says you describe a desired state in a deployment, and the deployment controller changes the actual state according to the desired state at a controlled rate. And what is interesting is that we've been uh, creating deployments, okay, but without describing, okay. We've not declared anything yet. So I'm expecting that in this documentation, this time there's going to be provision to actually create files. Okay, remember when we were studying deployments at the beginning, they said we can use either JSON files or YAML files. Okay, so I expect this to be there in this tutorial. Okay, because this is now a deep dive. Okay, and I don't want to be on the surface level of things, but I want to understand things at the core level. So it says you describe a desired state in a deployment, and the deployment controller changes the actual state to the desired state at a controlled rate. You can define deployments to create new replica sets or remove existing deployments and adopt all their resources with new deployments. And of course, we have been doing this using the scale command. In the previous tutorial, we used scale, okay, and the minus replicas subcommand to be on kubectl to be able to create replica sets. Okay, we've been using it to either scale up or scale down. Okay, if you remember. If you don't, you can watch the past videos. Okay, so let's continue into this deep dive. It says do not manage replica sets owned by a deployment. Consider opening an issue in the main Kubernetes repository if sorry, looks like every morning I got morning called. Okay, let's continue. It says do not manage replica sets owned by a deployment. Consider opening an issue in the main Kubernetes repository if your use case is not covered below. Okay, now let us go on to see the use cases. They say use case. Say there are typical use cases for deployments. They're saying the first one is create a deployment to roll out a replica set. Okay, so they're saying the replica set creates pods in the background. We have seen this. Check the status of the rollout to see if it succeeds or not. We have done this. Okay, so if you don't know, please check and see the past videos where we go through how to create replicas, and we verify that actually pods are created in the background, and we've been able to check out the rollout status. Now they're saying the other use cases declare the new state of the pods by updating the pod template spec of the deployment. Okay, we've not done this, okay, like manually. They're saying a new replica set is created and the deployment gradually scales it up while scaling down the old replica set, ensuring pods are replaced at a controlled rate. Okay, so good to know. And we have done or studied all this, and we have seen it in action. It says each replica set updates the revision of the deployment. Okay, we go ahead. Says roll back an earlier deployment version if the current state of the deployment is not stable. Each rollback updates the revision of the deployment. We saw this also. They're saying scale up the deployment to facilitate more load. We've also done this. They're saying pause the rollout of a deployment to apply multiple fixes to its pod template spec and then resume it to start a new rollout. Okay, we've not been able to manually update any template spec yet. Okay, so we have done scaling up, we have done rolling out something. Okay, to apply a number of fixes. Okay, they're saying update the status of the deployment as an indicator that a rollback has stuck. Clean up older replica sets that you don't need anymore. Okay, so these are the use cases. Let's go on. They're saying now create a deployment. They're saying the following is an example of a deployment. It creates a replica set to bring up 3 Nginx pods. Okay, so it's called control. It's in a directory called controllers/nginx deployment.yaml. Then if I look at it closely, okay, you see these are some of the things we looked at earlier. Okay, we have an API version, which is this. The kind, okay, of Kubernetes object is that's a deployment. Okay, then you have the metadata, which is information about it. The name that this is an Nginx deployment and has a label, which is Nginx. Okay, so if you wanted to access it, you'd say metadata.labels.app, and the value you would get is Nginx. So you'd say metadata.name, and you'd get Nginx deployment. Okay, let us now in the spec. Now is that there are replicas. See, there are 3. Okay, so 3. This is how. Yeah, very simple. Just by doing this, we have 3 replicas. Okay, and that simply means 3 Nginx pods. And then you have selector, match labels, app, Nginx. Okay, I'm saying template, metadata, labels, app, Nginx. Okay, there's no need to cram all this. Okay, spec. Okay, containers. I guess there should be a place where we can go and discuss all this in detail. Okay, but at least the point from this, okay, is that we are creating a deployment with a replica set, okay, of up to 3 Nginx pods. How do I know that? Okay, first of all, how is it a deployment? The kind of object being created is a deployment. That's the first thing I get to see here. Okay, that's how I know that this is a deployment, by this kind. Okay, and the number of replicas are specified here. Okay, that these are 3, and and the kind of image, okay, we are using is Nginx. Okay, this is the image Nginx at this particular version, running on port 80. So if I wanted to create a deployment, okay, a similar deployment, what I would do, okay, is simply to copy all this. Okay, I would copy all this and use it. Okay, use it the same way. So look at this. They're saying in this example, a deployment named Nginx deployment is created, indicated by the .metadata.name field. Okay, and that is this one here. Metadata.name. What is metadata? Metadata.name. Okay, is the name of this deployment. And then they said this name will become the basis for the replica sets and pods which are created later. They're saying see writing a deployment spec for more details. Okay, so I guess we may need to look at this. Okay, to understand what writing a a deployment spec is all about. Okay, but this is not for today. Okay, so I think it's actually below this. Okay, then they're saying the deployment creates a replica set that creates 3 replicated pods indicated by .spec.replicas field. Okay, deployment creates. So when we create a deployment, okay, automatically the pods are created for us. Okay, and they are indicated by the .spec.replicas field. So if I go up, spec.replicas field, that's what indicates that. Okay, so yeah, so that's that part. If I went on, just saying the .spec.selector field, the .spec.selector field defines how the created replica set finds which pods to manage. So spec.selector okay, defines how, the same way as a statement, defines how the replica set finds which pods to manage. Okay, and they're saying in this case, you select a label that is defined in the pod template app nginx. Okay, so this one here, okay, where is it? I want to make sure so apps the spec.selector is one which defines how the created replica set finds which pods to manage. So app.selector, where is app.selector? App.selector. Where is it? Have I misread it? It is spec.selector, okay? Not app.selector, sorry. Spec.selector. So spec.selector, okay, defines how it is going to find the pods, okay? So it's going to find the pods using this label, okay? This is now starting to make sense. They're now trying to explain each bit. When I move on, they're saying, so you're saying in this case, you select a label that is defined in the pod template app nginx. So this is app nginx. This is the label. Okay. So it will use this, okay, to find the pods. The replica set will use that name to find the pods. They're saying, however, more sophisticated selection rules are possible as long as the pod template itself satisfies the role. Okay. So they're saying note the .spec.selector match labels field, okay, is a map of key value pairs. A single key value in the match labels map is equivalent to an element of match expression whose key field is key, the operator is in, and the values array contains only value. Okay, all of the requirements from both the match labels and match expressions must be satisfied in order to match. Okay, so they're talking about this other part here, the match labels. Okay, they are key value pairs. Okay, that's the key takeaway from this note. Then they go ahead to say the .spec.template field contains the following subfields. Okay, so they're explaining it. The .spec.template spec, okay, the template. So just a recap. This one, metadata.name, specifies the name of the deployment. Okay, and this one here, spec.replicas, specifies the number of pods which will be created in the replica set. Then selector.match match labels.app specifies how specifies the label that the replica set will use to find its pods. Okay. Then now we're going to spec.template, okay, which is this one here. Spec.template. I think maybe I should create this thing. Okay. Let me copy it and go to here. Okay. Clear. Okay. Okay, there's nothing here. Then I'll just go into projects. Okay. Make a directory called cube. Okay. So cube lan. Okay. Then I create that file, copy the contents, -i, and paste them here. Okay. So that I can always refer to it. So you can also do it in your own editor of your choice. Okay. I've decided to use Vim. Okay. So now, so that I don't have to always scroll up to see the spec. So it's saying spec.template contains the following subfield. It says the pods are labeled app.nginx using the metadata labels field. Okay. So if we go to spec.template, okay, and the thing you're saying using the metadata.labels. So metadata.labels.app. So the pods are labeled using this. Okay. So talking about a spec, the template has subfields. One of them is metadata.labels.app. Okay. This is used for, this is the name that is given to the pods. Okay. It is used for naming the pods. Okay. All right. Says the pods template specification or.spec field, okay, indicates that the pods run one container nginx, which runs the nginx Docker Hub image at version this. Okay. And so they're saying spec, which is this one here. The spec field is this one here. Okay. Show that we're running this nginx version. Okay. Which will be got from Docker Hub. Okay. The name of the image is that. Okay. So you're saying create one container and name it nginx using the spec containers name. Okay. So this is the name of it. Okay. So when you see container 0, it means the first container, which means you can have more than one. You get. And it runs on port 80. Okay. So this is how I've understood it. We have a deployment, okay, object, which is named nginx deployment. We have 3 replicas. Okay, speaking of replicas, shows the number of pods in our replica set. There will be 3. Okay, and this one shows the name. Okay, selector.matchlabels.app. Okay, is the value which simply tells the deployment how to find the pods. Okay, the pods will be named by this name. Okay, and that name is actually inside here. You get. So this is the actual name of every pod. So we put it in template.metadata.labels.app. So there's no need actually to cram all this. Okay, you can always copy it from the documentation, from the internet, and then reuse it. Okay, so yeah. So ideally, how I'm getting it is that actually these names have to match. Okay, because it will look for this name. Okay, to find the pods labeled by this, and the actual label you defined it here. Okay, and it's now the container. Nice. So they're saying before you begin, make sure your Kubernetes cluster is up and running. Follow the steps given below to create the above deployment. Okay. So I'm going to start my Kubernetes cluster. Okay. I'll clear the screen and say minikube start. By default, a different driver is used. Okay. And I mean, by default, the Docker is used as the Docker desktop is used as the default driver. But I've seen people use something called Hyperkit. Maybe I'm going to try it later today. So we can now saying create a deployment by running the following command: kubectl apply -f. Okay, so they're referring to this file. Okay, if I copied this file like this, I paste it. Let me see if it will be accessible if I access it directly. Okay, it's just being trying. It's an actual file, and the browser was actually trying to download it. No problem. So I guess I can either apply this directly. Okay, I mean like this using the URL, or rather I can use this very one which I have, okay, on my machine. Okay, so I guess it is not mandatory to use this one. Okay, so let me use the one I copied because it's the same thing. Okay, so it's a kubectl. So that's why I say this is a deep dive. We hadn't done this before. Kubectl apply, okay, minus f. I say the nginx deployment. So I can either specify do this, okay, using the file which is on my machine, or specify their file which is on the internet. So now I hit enter, say deployment created. So if I say kubectl get deployments, okay, you see that we have 0 out of 3, okay, and 0 are available, okay. So current versus desired. Let's go on. They're saying run kubectl get deployments. We check if the deployment was created. If the deployment is still being created, the output is similar to the following, okay? And this is exactly what I get. So they're saying when you inspect the deployments in your cluster, the following fields are displayed. Saying the name lists the deployments in the namespace, okay, which is the nginx, this is the name, okay, nginx deployment. Then we have the read, displays how many replicas of the application are available to your users. It follows the pattern ready versus desired. Okay, so we desire 3, but 0 are ready. Okay, yeah, this is a good revision. It says up to date displays the number of replicas that have been updated to achieve the desired state. So for now, 0 have been updated to achieve the desired state. Then next up, they talk about available. Says displays how many replicas of the application are available to your users. And in this case, it shows what? 0. Next up, the age says age displays the amount of time that the application has been running. And if I check here, it has been running for 11 seconds. Says notice how the number of desired replicas is 3 according to the spec.replicas field. Yes, and that's correct. If I open the spec.replicas field, vim nginx.yaml spec.replicas field is showing 3. Okay, so when we go back here, we also see that the ones that are desired is 3. Okay, because our specification said that we need 3 replicas. Okay, so we have 3 replicas, which is okay. And right now, 0 are ready. So they're saying to see the deployment rollout status, run kubectl rollout status deployment nginx deployment. Okay, the output is similar to this. Okay, so you can say kubectl rollouts status deployments. Okay, in fact, we can just copy the whole command to save time. Copy it, close this, and paste it. Okay, so it has successfully rolled out. Okay, but if I typed it immediately, I would have something like waiting for rollout to finish. Okay, creating this out of this. Okay, let me try to do this. If I say kubectl destroy, okay, deployments, I want to just copy this other part. Unknown command destroy. How do you destroy a deployment? Okay, I guess it's something to Google. How to destroy deployment in how to destroy Kubernetes deployment. I guess this is something, I think, yeah, it is delete. It is delete. So I'll go back up, use the same command. And instead of destroy, say delete. Okay, so this has been deleted from the default namespace. So now if I run the command kubectl, let me clear again, I can now say kubectl apply -f nginx deployment, like that. I say kubectl get pods. Okay, you see that we have 3 pods. Okay, then if I say kubectl get deployments, see, okay, all of them are now ready. Wow, this was instant. Okay, let me try to do this. I want to delete. Okay, then try to apply and try to get deployments immediately. Okay, I think because of it must be having some kind of catch. Okay, it was very, very fast. Okay, so if I run the kubectl rollout status, okay, it should confirm that everything is okay. I thought if I delete and immediately check for the deployments, it would it would show a delay like previously, but it hasn't. Okay, so I think it catches what you did previously. So it's saying run the kubectl get deployments. A few seconds later, the output is similar to this. Okay, nginx deployments 3 out of 3. So we desire 3, and 3 are ready, and 3 have been updated to reach our desired state, and 3 are available for use. That is exactly what we get when I do this. Okay, and the edge is 56 seconds yet. So you're saying, notice that the deployment has created all 3 replicas, and all replicas are up to date. They contain the latest pod template and are available. Okay, that is okay and good. So you're saying to see the replica set rs created by the deployment, run kubectl get rs. The output is similar to this. Okay, so let us run the command saying run kubectl get rs. See the replica set. Okay, and this is what we get. Okay, this makes sense. You see, we have the name. Okay, it's the nginx deployment with this random string attached at the end. The desired state is 3, the current state is 3, and ready are 3. Okay, so we desire 3, and actually all the 3 are available. Okay, and this is the current age. Okay, since time of creation. All right, so you see the replica set shows the following fields. Name lists the names of the replica set with replica sets in the namespace. Desired displays the desired number of replicas of the application, which you define when you create the deployment. This is the desired state. Current displays how many replicas are currently running. Ready displays how many replicas of the application are available to your users. Age displays the amount of time the application has been running. Okay, and they say, notice that the name of the replica set is always formatted as deployment name dash hash. They're saying this name will become the basis for the pods which are created. They're saying the hash string is the same as the pod template hash label on the replica set. Okay, so what are they referring to? They're referring to this. Okay, so this is the pod name. Okay, then the hash. Okay, just think about it as the uh, a, a label, okay, to identify the replica sets. Replica sets, can I call it automatically? Okay, so they're saying to see the labels automatically generated for each pod, run kubectl get pods, okay, minus show labels. The output is similar to this. Okay, so let's do that command. I'll clear saying kubectl get pods minus show dash labels. Okay, I hope I'm correct. And there we are. Okay, if I expand this a little, we see everything. Okay, we see the label for the first pod. Okay, the label for the second pod, the label for the next pod. Okay, so 3 labels, and all of them are following the same syntax. The deployment name, they mean the deployment name, yes, and the random hash at the end. The deployment name, then the random hash, deployment name, then the random hash. Okay, this should actually speak to you. For me, I see that now all the deployment, this should be actually be the same. This makes sense that the first should be the same because they are pods of the same deployment. What changes is the random hash at the end to uniquely identify each of the pods. Okay, now I want to see if I say kubectl get pods, what I get. Okay, the same thing actually. So you see the deployment name, then a random hash, but this random hash is different for each of them. So 3, okay, 3 pods. Okay, and that's what I like about this deployment. The deployment simply created for us the pods. Okay, and everything is being managed. Okay, the deployment makes sure that our desired state, our current state, reaches the desired state. All right, so let's continue. It's a bit nice. Since the replica set ensures that there are 3 Nginx pods. Okay, like we have seen. Okay, our replica set has ensured that there are 3 Nginx pods. Okay, I want to try something. What if I try to recreate the deployment? Let me say kubectl apply -f Nginx deployment. Oh, I like this. I like this. Are you seeing this? Says unchained. What if I try to apply the same but from the internet? Let me see if it will try to get confused. Where's that URL? We had the URL somewhere. This is very good. What has happened to this page? That URL was somewhere up. Right here. This is what I'm looking for. I want to copy it. Come back here. kubectl apply. But this time using this. Okay, remained unchanged. So it was smart enough to know that this configuration here, okay, in my local file is the same as the one from the internet. So it remained unchanged. That's the best thing for it to do. Let me first reset this and then zoom in again. I don't know why it's doing this. Let me try to refresh this page. This should be, I wanted it to collapse this left menu, but it's okay. Let's continue. Okay, they're saying note, you must specify an appropriate selector and pod template labels in our deployment. In this case, app Nginx. Okay, they're saying do not overlap labels or selectors with other controllers, including other deployments and stateful states. Do not overlap labels or selectors with other controllers, including other deployments and stateful states. Okay, they're saying Kubernetes doesn't stop you from overlapping. Okay, we're not stopping from overlapping. And they're saying, and if multiple controllers have overlapping selectors, those controllers might conflict and behave unexpectedly. Okay, so you should make sure that these selectors are unique. Okay, so in our case, if I just show you, say vim nginx deployment. Okay, so the selectors should be unique. So selector dot match labels app nginx. Okay, they have to be unique. We should not overlap. So I'll remove this. think we have understood that point. Okay, they're saying pod template hash label. Caution, do not change this label. Okay, we are listening and we're taking heed to the advice. Now they're saying the pod template hash. The pod template hash label is added by the deployment controller to every replica set that a deployment creates or adopts. They're saying this label ensures that the child replica sets of a deployments do not overlap. Okay, and we have known why they should not overlap to avoid unexpected behavior. Next up, they're saying it is generated. Okay, they're saying it is generated by hashing the pod template of the replica set using the resulting hash as the label value that is added to the replica set selector. Pod says it is, I want to read this again, it is generated by hashing the pod template of the replica set and using the resulting hash as the label value that is added to the replica set selector, pod template labels, and in any existing pods that the replica set might have. Okay, as simple as that. Is simply used to make them look unique. Okay, now we're going to go to the next part, updating a deployment. Okay, I like this deep dive so far. Okay, this is a very, very good deep dive. Okay, and like I told you, mastery simply means repeating something over and over again. So I'll go on the saying note. The saying, a deployment's rollout is triggered if and only if the deployment's pod template, that is spec.template, is changed. For example, if the labels or container images of the template are updated. Other updates such as scaling the deployment do not trigger a rollout. Okay, so a rollout is triggered only if the spec of the template is changed. For example, the labels or the container images are updated. So let's go and find out this the .spec.template. If I open that file, so spec, this is the spec.template. Okay, so they're saying that a rollout is triggered only if we change, for example, this. Okay, if we change this label. Okay, so remember this label is a label for the containers. Okay, so you're saying if we change the label or if we change the image. Okay, if we change this image, that is only what triggers a rollout. Okay, but if we scale, okay, if we scale our deployment, okay, it does not trigger a rollout. Okay, take note of that. What changes? In simple terms, this is how I've understood it. Yes, Hasha. Long time. How are you doing, Hasha? Long time, Hasha. You've been lost. I'm sure you must be surprised that we are now learning Kubernetes. You must be wondering what is going on the channel. Yeah, but Hasha, I'm just trying to. This is what I do every morning. Okay, but in the evening we continue building the flight booking engine. Welcome back. Great to have you on the stream. So yeah, simply understand it. If you want a rollout to be triggered, simply make a change to spec.selector. Okay, anything here will trigger, any change made here will trigger a rollout. Okay, that is what this note is saying. Okay, that only if the labels or container images of the templates are updated, that is when we trigger a rollout. Okay, but if we scale a deployment, we cannot trigger a deployment. Okay, and I'm hoping that maybe later down they'll show us how to do it. Okay, actually it's here. They're saying follow the steps given below to update your deployment. Okay, now they're saying step 1, let's update the Nginx pods to use Nginx 1.16.1. Okay, 1.16 instead, to use the Nginx 1.16.1 image instead of the Nginx 1.14.2 image. Hasha says, long-term buddy, I was offline for a bit because of a project. Back now. I understand, Hasha. That's how the hustle goes on. Okay. Yeah. Welcome back. How was the project? What was that project you're working on? Was it a full stack project, back end, front end? It must be have been a really long project because you've taken some time, about probably 3 weeks, if I'm not mistaken, 3 weeks to a month. Great to hear that. Okay. So we now, if you check our spec, okay. Wow, I shouldn't have closed it. Okay, you see, we're using this Nginx version. Okay, 1.14.2, but I want to change it to 1.16. Okay, 1.16.1. So to do that, remember how we did it? I think either yesterday or the other day, that we simply do this. We use the set image command. Okay, set image command, mention the deployment. Okay, mention the deployment and change the image. Just the image that is changing. Okay, so set image. How does set image simply work? Let me remind you. Set image works by specifying the deployment whose image you want to change. Okay, and you specify the image and the new version. Okay, so in our case it is Nginx that we want to change, the name of the image that we want to change. To which version? This version. Okay, and this is the deployment that we want to update. Okay, so I'll copy all this and paste. Okay, says deployment.apps Nginx deployment image updated. Okay, good news. We continue. Oh, they're saying, or use the following command. Okay, yeah, actually this is what we started yesterday or the other day, that you use kubectl set image deployment, then the name of the deployment. So this part here, deployment, and here, okay, it's the same thing. Okay, so you see this other part is identical. This part is also identical. Okay, so they're saying where deployment Nginx indicates the deployment. Okay, so this is the actual deployment. But remember, a deployment has, of course, the image that we're going to change. So they're saying Nginx indicates the container, the update will take place. Okay, Nginx indicates the container, the update will take place, and Nginx 1.16.1 indicates the new image and its tag. Okay, so this is the container. Okay, it's saying the output is similar to this. It's saying deployment.apps image updated. If we go here, we see the same thing. Okay, image updated. Then we continue saying, alternatively, you can edit the deployment and change spec.template.spec.containers. The first container, which 0 means first container, because it expects a list of containers, meaning a list can have one or more items. And the first item in that list is at position 0. Okay, so it says spec.template.spec.containers, the first one, okay, .image, from this to this. Okay, so we can edit that, okay, using this command kubectl edit deployment. Okay, and the output would be similar to this. Okay, so they're saying we can either, remember we learned about set image. I want you to understand this first of all. Okay, let us go slowly. They say the first thing you can say is kubectl, okay, set image. Okay, so to set an image, images are tied to a deployment. Which deployment do I want? I want the deployment. Okay, first of all, if you don't know the deployments, you can say kubectl get deployments. Okay, get deployments, like that. So you see we have a deployment called Nginx deployment. Then I can say kubectl, okay, get set image, okay, of which deployment. The deployment which I want to set is in deployment, okay, deployment slash Nginx deployment, this one here. Okay, because there can be more than one deployment, so you have to specify that. Then the container is Nginx, okay, to which image, to which version. Okay, let's now this other version, Nginx 1.16.1. Okay, so I can say the image is now Nginx x : 1. 16.1 and hit enter. Okay, but of course it won't change. Okay, but I can change it to 14.2. 14.2 again. See, it says image updated. Okay, this is one way of doing it. So I want to check, has this file been changed? If I open it, okay, it is 1.14.2. Now I am going to clear, okay, and change it back to 16.1. 16.1. Okay, it says image updated. Now I'm going to check that file. Has it changed? Okay, you see it is 1.14.2. Okay, so now you should know that this set image changes it as the cluster is running, but that file won't change. Okay, Hash already says he has been working on a full stack web and app project. We are almost done, but we are stuck on the backend. You are great with backend. Could you jump in and help us finish as soon as possible? Yeah, that is something I could consider. Okay, you can write to me. You can write to me and tell me what your backend is all about, what stack you're using, what you've done so far, what uh, what you want to be, what has not been done. Okay, and then we can uh, we can we can go ahead and work together. Okay, says which backend should which backend should you use for auth, storing user details, and sending real-time OTPs via phone numbers? Ideally, I would create the backend using anything. Okay, I shall use, if it is Django, I would use Django. If it's a fast API backend, I would use fast API. If it's Java, in that case, the language wouldn't matter. Okay, wouldn't matter. Yeah. So to send real-time OTPs via phone numbers, okay, you might want to use this tool, the tool called Twilio. Okay, look at Twilio. Okay, it's a company known for doing SMSs. Okay, implement their API. Okay, for messages. See, say send, receive, and manage multi-channel text messages on our globally reliable platform. All right, let's continue. So that is one way, but they're saying we can change the spec. So spec.template. I want to show you this. Okay. So if I go to Nginx deployment, they're saying spec, okay, dot template, okay, then spec dot template dot spec dot containers, okay. Then the first container, which is this one, we can change the image, okay, to 16.1. Okay, by saying kubectl edit, okay. So let us do it. So kubectl edit, okay, and what they're saying, I said what do I want to edit? I want to edit the deployment, which is the Nginx deployment. Okay, I want to fix a spelling mistake I've seen. Instead of Y at the end, it's supposed to be a T, like that. So if I hit enter, okay, there we are. Okay, I seen this. So we can now do edits, okay, to this. Okay, so if I go up, what even before I edited anything, I want to see what they say. Okay, they're saying we should get an output like this. So I'll go to that line, okay, and go to, where's that line? Yeah, inline edits on a long file are very hard. Okay, so I don't know if I just can just click. I can't click on a point. I have to keep moving until I reach that specific part. So let me try to move the cursor as fast as possible. So Hasha, yeah, write to me, including information like the amount of time you'd want me to give per day, and of course the compensation. So we change this, okay? We change this to, so to edit, you press I, okay? Because remember they're using the VI editor. So to edit, you press I, guys, okay? Editor says 16, okay? It's 16.1, okay? Then I close. Okay. You see they're saying deployment edited. That is exactly what we expected to see. And they're saying to see the rollout, they're saying run this. Okay. You can copy this. Okay. Saying successfully rolled out. Okay. Let me try to edit again. Wow. Being able to do this manual actually hurts. Okay. Let me not do that, but you get the point. Okay. I wanted to edit again and then I make you to see the rollout. Okay. So you see what it says edit cancelled, no changes made. So it is smart enough to know. So kubectl edit deployment, nginx deployment. Okay. Is how you can do it. Okay. So multiple ways. Okay. To edit a deployment. Okay. We can either use set image. Okay. Or use kubectl edit. Kubectl set image or kubectl edit. I would prefer editing because if I wanted to share the specification with people on my team, okay, it would be, can I say, it is shareable. Okay, that's the point. It is shareable. Everybody, because it's the file being changed, anybody else will have access to it. So they're saying the output is similar to this. Of course, ideally, if we had done it immediately, okay, we would see this output saying waiting for rollout to finish. 2 out of 3 replicas have been updated. We would see something similar to this, okay? But because I went on editing and doing other things, okay, it was successfully rolled out. So if it has not been successfully rolled out, we should see a message similar to this. But for us, we got this, okay? A good success. So I want to continue. It says, get more details on your updated deployment. So it's saying after the rollout succeeds, you can view the deployment by running kubectl get deployments. The output is similar to this. Of course, by now we should know this. Okay. I expect everybody who has been learning for the past 14 days, okay, to be able to know what this does. Okay. So they're saying run kubectl rs to see that the deployment updated the pods by creating a new replica set and scaling it up to 3 replicas, as well as scaling down the old replicas to 0. Okay. So kubectl get rs. Okay. So you see, all is as mentioned. Okay. So you're saying the output is similar to this. So what happened? Okay. The deployment updated the pods by creating a new replica set and scaling it up to 3 replicas, as well as scaling down the old replica set to 0 replicas. So the old one, okay, was scaled down to 0. Okay, you see, it has 0 in its current and 0 in its desired. The new one has 3 in our current state and 3, of course, are desired. So the goal always, when you create a deployment, the goal is to ensure that the current state matches the desired state. Who does that? The controller, the kube controller. In this case, is the deployment controller that takes care of that. All right, let's go ahead. They're saying running get pods should now show only the new pods. Okay, I'll clear kubectl get pods. Okay, my spelling is wrong. CTL. Okay, and there are our pods. Okay, perfect. Very nice. Okay, say output is similar to this. That's correct. They say now next time you want to update these pods, you only need to update the deployments pod template again. Okay, isn't that a good thing? That if we want to update the pods, all we need to do is to update the template. Now they're saying deployment ensures that only a certain number of pods are down while they are being updated. Okay. They're saying by default, it ensures that at least 75% of the desired number of pods are up, okay, which is 25% max unavailable, okay? So 25% are unavailable, 75% are available. So it says deployment also ensures that only a certain number of pods are created above the desired number of pods. Okay, deployment also ensures that only a certain number of pods are created above the desired number of pods. By default, it ensures that at most 125% of the desired number of pods are up. Okay, so 25% max surge. That's very good. Okay, okay, this is very good. So it creates more than the desired. Okay, 125%. Great. So they're saying, for example, if you look at the above deployment closely, you will see that it first creates a new pod, then deletes an old pod, and creates another new one. Okay, so it says it does not kill old pods until a sufficient number of new pods have come up. Okay, now guys, I think now you're starting to see why people like Kubernetes. Okay, and they're saying, and does not create new pods until a sufficient number of pods have been killed. Okay, it does not kill pods until a sufficient number of new pods have come up, and does not create new pods until a sufficient number of old pods have been killed. This is why people like Kubernetes. Okay, it makes sure that at least 3 pods are available, in that at max and that at max 4 pods in total are available. Okay, in a case of a deployment with 4 replicas, the pods would be between 3 and 5. Okay, so all the pods are not just killed. Okay, it makes sure that a good number of new pods are available. Okay, okay, so and also it doesn't just create new pods certainly. Okay, it creates new pods according to how the number of old pods have been killed. So it's saying get details of your deployment. Okay, by now we should know this command, describe. Okay, okay, we know what describe is all about. Using output is similar to this. Okay, now they're saying here, you see that when you first created a deployment, it created a replica set, this, and scaled it up to 3 replicas directly. Okay, when you updated the deployment, it created a new replica set, this, and scaled it up to 1 and waited for it to come up. Okay, so it first created one new one. Okay, then it scaled down the old replica set to 2. Okay, remember the old replica set were 3. Okay, so it first created one more to make them 4, then deleted one old one, okay, to make it 2, then scaled up the new replica set to 2, okay, so that at least 3 pods were available, and at most 4 pods were created at all times. Okay, that's nice. Okay, read this again carefully. Then it scaled down the old replica set to 2 and scaled up the new replica set to 2, so that at least 3 pods were available and at most 4 pods were created at all times. Then it says it then continued scaling up and down the new and old replica set with the same rolling update strategy. Finally, you have 3 available replicas in the new replica set, and the old replica set is down to 0. So if I go back here, where are the events? So I think we can start. Yeah, look at this. Old replica set. Okay, 0 out of 0. Okay, new replica set, 3 out of 3. Okay, so let us go here and look at the events. Okay, maybe we can start from down here. Okay, I see. Say scale down replica set from 1 to 0. Okay. Then again, scaled up replica set from 2 to 1. Okay. Then here says scaled down replica set from 2 to 1. Okay. Check the hashes. Okay. These hashes are different of the replica sets. Okay. Then if you come here, says from 1 to 2. Okay. So it has the logs of everything. Okay. How it moved between the states. Okay. How it moved from the states. Okay. So you see, finally, this one here with this hash was moved from 0 to 3. Okay. Then this one, I think this one, which is the same as this one, from 3 to 2. Then this other one here from 1 to 2. Okay. So these are just the events. Okay. Okay. And that is what is explained here in this. So yeah, you can read this again in your free time. Just make sure you understand it. So if you're enjoying this is the time when you like the video, okay? And share it with your friends in your network. Okay, so I want to read this note. They're saying note. Kubernetes doesn't count terminating pods when calculating the number of available replicas, which must be between replicas minus max unavailable and replicas plus max surge. As a result, you might notice that there are more pods than expected during a rollout, and that the total resources consumed by the deployment is more than the replicas plus max surge until the termination grace period seconds of the terminating pod expires. Yeah, but this makes sense. So during a rollout, it creates more pods, okay, just to make sure that everything is okay, okay, and we have enough pods to be able to sustain, okay, to sustain the rollout. I'll continue, okay, another topic. They're saying rollover, aka also known as multiple updates in flight. So they're saying each time a new deployment is observed by the deployment controller, a replica set is created to bring up the desired pods. Okay, each time a deployment is observed by the deployment controller, a replica set is created to bring up the desired pods. Okay. So there's something I'm missing. It's the word new. It is each time a new deployment, not each time a deployment, but each time a new deployment is observed by the deployment controller, a replica set is created to bring up the desired pods. Okay, good to know. Now they're saying if the deployment is updated, the existing replica set controls the pods whose labels match .spec.selector, but whose template does not match .spec.template are scaled down. Okay, so it is comparing .spec.selector to .spec.template. So it looks at the labels, okay, and says I want a pod, okay, in the existing replica set, okay, whose labels match .spec.selector, but the template does not match .spec.template, okay. And then it says eventually the new replica set is scaled to .spec.replicas, okay, and all old replicas is scaled to 0, okay. So just to show you, Nginx. So talk about spec.selector and spec.template, okay. So it looks at spec.selector, okay, and then spec.labels, okay. This simply compares those two, okay. So don't get confused, okay. And sometimes to even understand the things, you have to read them over and over again. Actually, when will you be free? Today I don't have time. Yeah, today I'm kind of occupied after this stream. I'm going to get back to my day job. Probably, let me see. Today is, I need to look at my calendar. Okay, we can create time and talk about it. Write to me, okay, with your availability. Let's see, probably Friday morning, okay, around 10 a.m. East African time. We can have a quick call about it. All right, let's continue. So, where are we? Okay, here we are. It says if you update a deployment while an existing rollout is in progress, the deployment creates a new replica set as per the update and starts scaling that up and rolls over the replica set that it was scaling up previously. It will add it to its list of old replica sets and start scaling it down. Okay. So I think it simply overrides the other one. Wow, this is now getting deep. Okay. This is now getting deep into issues. Okay. So they're saying, for example, suppose you create a deployment to create 5 replicas of this. Okay. But then update the deployment to create 5 replicas of this. Okay. So this is Nginx 14. This one is Nginx 16. Okay. Initially, we have a deployment of 5 replicas of Nginx 14. Then later, we have a deployment with 5 replicas of 16. So that's a change. So saying when only 3 replicas of 14 had been created. Okay. So when only we want 5 of 14. Okay. But as 3 so far have been created. Okay. Not yet 5. Okay. We again say now update it to give us of 16. Okay. So when only 3 have been created of Nginx 14, in that case, the deployment starts killing the 3 Nginx 14 pods that it had created and starts creating Nginx 16 pods. It says it does not wait for the 5 replicas of Nginx 14 to be creating before changing course. Nice. I like this. Okay. I like this. Yeah, Nginx is really, Kubernetes is really smart. Okay. Really smart. These guys who did this, yeah, it is safe to say they are really smart people. Okay. Really smart people. This is good. Asharod is asking, Dancer, would I make a Google Meet or call? Yeah, set up a Google Meet. Okay. Yeah, I can find it in my email. Set up a Google Meet. So not labor. What's wrong with me? Label selector updates. It is generally discouraged to make label selector updates, and it is suggested to plan your selectors up front. Okay. So they're saying in any case, if you need to perform a label selector update, exercise great caution and make sure you have grasped all of the implications. Okay. So yeah, discouraged to make updates of the labels. Okay. Let's continue. They're saying note in API version. Okay. In API version apps v1, a deployment's label selector is immutable after it gets created. Okay. And I think that's what we are working with. See apps v1. Okay. It's immutable, so it can't be changed. Well, how far we? I want to see how far we are from getting done with this. Wow. There's a lot to cover. Okay. I'm thinking I might have to just do a part 2. Okay. Because my mind is getting tired. And I'm also saying I'm running out of time to get back to work. So I want to see how much we can cover before I get back to work, okay? So I will maybe stop at this paragraph, okay? Then continue from this other part tomorrow, okay? There's no need to force the brain and to to get stuck, okay? And because also studying for too long can instead bring brain fog, and we don't you don't understand much, okay? So let me read this. The saying, okay, now we're being told it's bad, okay? We are discouraged to make updates, okay? And the saying in this version of API of Kubernetes, it is immutable, okay? The deployment label selector is immutable after it gets created. So let's see what they're saying here. They're saying selector additions require the pod template labels in the deployment spec to be updated with the new label too. Selector additions require the pod template labels in the deployment spec to be updated with the new label 2. Otherwise, a validation error is returned. Okay? They're saying this change is a non-overlapping one, meaning that the new selector does not select replica sets. And pods created with the old selector, resulting in orphaning all old replica sets and creating a new replica set. This change is a non-overlapping one, meaning that the new selector does not select replica sets and pods created with the old replica, resulting in orphaning all the old replica sets and creating a new replica set. So they say selector updates changes. Selector updates changes the existing value in a selector key, result in the same behavior as additions. Selector updates changes or selector updates change the existing value in a selector key, result in the same behavior as additions. Am I tired, or is it me failing to read properly? I need help. Selector removals removes an existing key from the deployment selector. Do not require any changes in the pod template labels. Existing replica sets are not orphaned, and a new replica set is not created. But note that the removed label does the. I want to read this again. Selector removes an existing key from the deployment selector. Okay. Then it goes on to say, do not require any changes. This does not require any changes in the pod template labels. They go on to say existing replica sets are not orphaned, and a new replica set is not created. But note that the removal label still exists in any existing pods and replica sets. Okay. Wow, it's been a lot to study today, and I've run out of time. Okay, so I have to get to work, and I see, yeah, we have a lot more to cover. So yeah, we'll continue learning tomorrow, and yeah, getting better and better at Kubernetes. Okay, I hope you've loved this deep dive. Okay, after this deep dive, actually, tomorrow we're supposed to go into now examples, okay, of applications, but let's finish this tomorrow and get back at it. Okay, again, does not matter how long it takes. What matters is how much I learn, how much you learn. Okay, this is just 14 days since we begin learning. Okay, not even a month. Okay, so it is actually little. So imagine what it will be like 1 month of studying Kubernetes. Okay, 30 days of studying Kubernetes. So it's all about consistency and repetition. Do not give up, and be encouraged to learn and master this useful skill. Bye for now, and see you in tomorrow's learning session. For those building the flight booking engine, if I have time today in the evening, I'll send an update, okay? But for the morning lesson on Kubernetes, we'll be there tomorrow. Bye for now and talk soon.